Okay guys, Timmy coming at you here. And today, what I want to do is I want to go over the concept of osmosis. Now, I can't even begin to tell you how important this is. And if you're ever going to understand diabetes and why people pee a lot, drink a lot, eat a lot, when their blood sugar is really high, you have to understand this concept. And if you do understand this concept, then let's say, for example, you're working in an emergency room and someone comes in and their blood sugar's 900. Well, one of the things you have to do is you have to give them IV fluids. And the reason you do that is based on this idea of osmosis. And if you understand that, then you'll totally understand why you have to give them a bunch of IV fluids when their blood sugar's high. So let me review that, and well, not review it, but go over it. And I really want you to get this, and I'll be honest with you, there's going to be some questions on the test about this because it's that important. And remember, if I tell you something's really important, then there's gonna be questions on it. It's just that simple. All right, so let's go over this. First of all, remember that the goal of the body is to maintain that internal balance. And one of the things that the body has to maintain, both in the blood and in the cell, is this concept called osmolarity. So osmolarity is a measurement. All right? And remember that in the blood, you got stuff and water, and inside the cell, you got stuff and water. And again, we don't care about what the stuff is. All we need to know is that there's stuff and water in the blood and stuff and water in the cell. All right? And remember, what's the goal of the body? Go ahead and answer it. I'm listening. And if the goal of the body is to maintain homeostasis, which of course it is, then there has to be a balance between stuff and water in the blood and stuff and water in the cell. You can't get around it. And again, who cares what the stuff is? All you need to know is that it's stuff, right? It ain't water. And if it ain't water, it's stuff. And remember, how thick is a capillary? You learn this. It's one cell membrane thick. And how thick is a cell membrane? It's one cell membrane thick. And all capillaries and all cell membranes are selectively permeable. What does that mean? That means that if there's something in the blood that the cell needs, there's going to be a way for that stuff to get into the cell. And if the cell has to get rid of some stuff and put it into the blood, then there's going to be a way for that cell to do that. That's selective permeability. And all cells have that. All right? Now, really, 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 really important. If stuff can't move, water can always move. And I'm going to go over this. I'm going to show you my little picture. I'm getting real close to the mic right now. If stuff can't move, water can always move. And water always moves. Water always moves from an area of low osmolarity through a selectively permeable membrane to an area of high osmolarity until the osmolarity of the blood and the cell are equal. So osmosis, I'm getting close to the mic again. Osmosis is the movement of water. The only thing that osmosis is water. Everything else diffusis is. What's the only thing? What's the only thing that osmosis is? Water. So osmosis is the movement of water from an area of low osmolarity to an area of high osmolarity through a selectively permeable membrane. What's osmolarity? Osmolarity is the ratio of stuff to water. And again, it don't make no never mind what the stuff is. So let's look. Watch. I'm making this up. I'm making it up. Osmolarity is a measurement. It measures the ratio of stuff to water in the blood and the cell. And what's the goal of the body? To maintain, one of the things is osmolarity of the blood and the cell. So I'm making this up. Watch. There's 100 stuffs and 10 waters. So the osmolarity of the blood is 10, because 10 into 100 is 10 in any language. Now, watch. You can increase osmolarity of the blood of the cell in one of two ways. Way number one is you can increase the stuff and keep the water the same. So you added more stuff to the blood, but you kept the water the same. So now the osmolarity is 20. Or you can keep the stuff the same and decrease the water. Look, we kept the stuff the same, but now we've just decreased the water, and that still comes out to 20. So that's how you can increase osmolarity. Same goes for decreasing it, right? Now look, real simple picture. Where's the only place in the body that nutrients are exchanged from the blood in the cell? Is at the capillary and the cell. And this is important. The ratio of stuff to water in the blood, or osmolarity, has to be equal to the ratio of stuff to water in the cell, or the osmolarity of the cell. So the osmolarity of the cell and the blood have to be equal. Otherwise, bad things happen. And you don't want bad things. You want good things. You should write that down. All right? So let me give you a real simple picture, and then let me explain it. Here we go. Watch. Again, it don't make no never mind the stuff. The ratio of the stuff to water in the blood, right here, and the stuff to water in the cell has to be equal. So in this picture, what I'm telling you is that the osmolarity of the blood and the osmolarity of the cell are equal, and life is good. But let's say, for example, something caused the amount of stuff in the blood to go up. If you added more stuff and you kept the water the same, if you add more stuff and you keep the water the same, what's going to happen to the osmolarity? The osmolarity of the blood is going to go up, right? Now, the osmolarity of the blood is higher. It's higher. That's an arrow going up. Than the osmolarity inside the cell. Now, if this stuff cannot move from the blood into the cell because it's impermeable, and it clearly is. You see that arrow disappearing? I didn't do that. If this stuff can't go from the blood into the cell, now we got a problem. We got a problem because the osmolarity of the blood is now higher than the osmolarity inside the cell. So what's our goal? Our goal is to have the osmolarity of the blood and the cell equal. So if this stuff that I just added to the blood is impermeable to the cell, it can't go in there. The osmolarity of the blood is now higher. But remember, wait, let's go back. If stuff can't move, what can always move? Water can always move. So where is the osmolarity high? In the blood. Where is it lower? It's lower in the cell. And if stuff can't move, water can always move. And water always moves from an area of low osmolarity or less stuff, more water, right? Through a selectively permeable membrane, water always moves from an area of low osmolarity through a selectively permeable membrane to high osmolarity. So if you're removing the water from the cell and putting that into the blood, the water is going to move from the cell into the blood until the osmolarity of the blood is equal to the osmolarity inside the cell. Now, what is osmosis? The osmosis is the physical movement of water from low osmolarity to high osmolarity until the osmolarity of the blood and the cell are equal. Now, why is that important? Why is that important? Well, I'm going to explain it to you. Watch. You watched the video on the homeostatic mechanisms and you learned about blood sugar. You also learned that the part of the brain that controls hunger, temperature, and thirst is the hypothalamus. We'll call it the H-thal. Or P. Diddy. Or just Diddy. Okay, that's stupid. The hypothalamus controls hunger, temperature, and thirst. Now watch. You have a sodium ion in the blood. Sodium is always highly concentrated in the blood. Sodium is always highly concentrated in the blood. Sodium is always highly concentrated in the blood. Did you write that down? Potassium is always highly concentrated in the cell. Where's potassium always highly concentrated? In the cell. Now watch. Let's say, for example, you take this class and you think, you know what? I don't know about this. I don't know about this guy. I don't know about this class. So I'm going to go to the Purple Sombrero and have me some drinks. So what do? You go to the Purple Sombrero. And of course, they serve popcorn and peanuts, right? And it's always a good idea to eat that stuff after people have been sticking their dirty, gooey hands into it. It's a good idea. Anyways, I digress. Watch. The reason they serve salty food, salty snacks at a bar, is because when you eat salt, which is sodium chloride, the amount of sodium in the blood is going to go up. Why? You just ate some. And where is sodium always highly concentrated? In the blood. Where's potassium highly concentrated? In the cell. What did you just do? You ate salt, sodium chloride. Excuse me. So now, what has happened to the osmolarity of the blood because you ate some salt? The osmolarity of the blood has gone up. So watch. What's the goal of the body? To maintain homeostasis. Now the osmolarity of the blood is higher than the osmolarity inside the H cell. Why? Because you added more stuff to it and kept the water the same. So if stuff can't move, what can always move? Better say it. Water. Water can always move. And water will always move from an area of low osmolarity, which in this case is the H cell, through a selectively permeable membrane to an area of high osmolarity until the osmolarity of the cell and the blood are equal. So, what did you do to the H cell? You kept the amount of potassium the same, but you decreased the water. So if you kept the amount of stuff in the H cell the same, but you removed the water, the osmolarity goes up. And anytime you increase osmolarity in the H cell, that triggers the H cell to tell you that you're thirsty. And you will drink. And what do bars hope? What they hope is that you don't order water, that you order another drink. That's why they do that. Now watch. Remember that when you eat sodium, right, you eat salt, the sodium goes up everywhere. Everywhere. Right? It goes up everywhere. All the cells of your body are exposed. All the cells of your body are now exposed to this increase in sodium in the blood. Potassium remains in the cell. Right? So the osmolarity of the blood is higher than the osmolarity inside the cell. So because of this, water from all the cells of the body are going to be, water from all the cells is going to get removed and go into the blood, because water always moves from an area of low osmolarity to an area of high osmolarity through a selectively permeable membrane. So all the cells are having their water removed due to this high osmolarity of the blood. And just remember this. What are you doing? You're adding water to your blood. And anytime you increase the amount of water in your blood, that says blood, that leads to an increase in blood pressure. That's why they tell people who have high blood pressure not to eat a lot of salt. Did you catch that one? That's why they tell them, a person with high blood pressure, they need to be on a low sodium diet. When we get later into the semester, I'm going to explain to you why people with diabetes pee a lot, drink a lot, and eat a lot. But that right there, that's top flight information. So, as I always do, leave you with this. Well, the education of Gateway Technical College students continues. That's the concept of osmolarity and osmosis. You need to know this. You need to be able to explain why water moves. You got me? All right. I hope that helped. You guys be good. Just so you know, I'm making this video on a Sunday right after it snowed. Kind of bothers me. Could have been out golfing, but what am I doing? Making a video for you guys. All right. Be good.